Hi, my name is Richard Leary, and I'm a member of the STEAM the Streets After School program, where I teach kids the basics of electricity and electronics, and also computer programming. I'm here today representing the E in STEAM, engineering. Engineers take a basic knowledge of science and technology and use it to design and build things such as buildings, bridges, computer and communication systems, transportation systems, wind turbines, electric cars, all kinds of things. There are different kinds of engineers: chemical engineers, civil, structural, mechanical, aeronautical engineers, environmental engineers. Engineers earn generally between $70,000 and $120,000 a year. I myself am an electrical engineer. I worked for 30 years at the Naval Undersea Warfare Center in Newport, Rhode Island, where I developed computer systems for the submarine fleet. It was a very interesting, rewarding, and lucrative career. I'm going to give a brief lesson on electricity and electrical circuits, and I'm going to show you how to use a free online tool to build a circuit. I hope you'll find it interesting. So what exactly is electricity? It's a good question. I'm going to try to answer that, and then I'm going to explain and show you how to build an electrical circuit using a free online tool called a circuit simulator. Electricity is electrons in motion. All matter is made up of atoms, and all atoms consist of a nucleus consisting of protons and neutrons. Orbiting around the nucleus are electrons. When electrons move from one atom to another, we then have the phenomena of electricity. We experience electricity in our daily lives, both naturally occurring electrical phenomena, as well as in the operation of electrically powered machines and devices. Here we have a spectacular display of lightning over a Midwestern city. And here we have Aurora Borealis, the northern lights, a wondrous quasi-electrical phenomena seen in the northern latitudes. Here, high-voltage electrical transmission lines carry energy from massive electrical generators to power our industries, cities, and homes. And electrical and electronic circuits play a huge part in the operation of all kinds of home appliances, such as refrigerators, lighting, personal computers, our cell phones, and televisions. Our vehicles are increasingly being converted from gasoline to electrical power, and our cars and roads are becoming integrated intelligent systems. We human beings cannot function without the electrical signaling that goes on within our bodies and our brains. And some animals, such as electric eels, can generate their own electrical fields as a defense mechanism. These are just some of the examples of electricity all around us. Think for a moment about a plumbing system, your home water system. Water is either pumped into the house or it flows in due to gravity. The water is directed to different parts of the house through pipes. The flow is controlled using shut-off valves and faucets, which can turn the water on and off and also control its rate of flow. An electrical system is very similar in many ways. We call a simple electrical system a circuit. In an electrical circuit, the source of electric flow is a battery or some other power source. Instead of water pipes, we have electrical conductors, typically copper wires. Instead of faucets and shut-off valves, we have resistors and switches. Finally, we have the devices themselves which we want to power. Here's a picture of a real basic electrical circuit, one which I'm going to show you how to build. It consists of a power source, in this case 2 AA batteries, a simple switch, a small incandescent light bulb, and connecting wires. To the right of the photograph is a diagram of the circuit. These kinds of diagrams are called schematics. In this diagram, the 4 horizontal lines are the symbol of a battery, the arrow symbolizes a switch, and on the right we have the symbol for a light bulb. The next slide shows the exact same circuit, but with a different kind of light, in this case an LED or light-emitting diode. Now let me show you how to build a circuit virtually online, since we are all at home and can't do it physically. To do this, we go to a website at the Boulder campus of the University of Colorado Boulder. In a browser, whether it's Chrome or Firefox or Internet Explorer or Safari, you're going to go to this website, phet.colorado.edu. And when you do that, you come to this main page right here. You're going to go up to Simulations, you're going to go down to HTML5, click that, you're going to click on this, then you're going to scroll down, click on Circuit Construction Kit, DC Virtual Lab, then click the right arrow. It takes a second to load, the simulation to load, and here's the simulation. We have a large blank area, which is the circuit assembly area. On the left, we have a number of circuit components: batteries, light bulbs, switches, wires. We're going to use those components to build our circuit. Over on the right here are some settings. We just want to click conventional, which will change how the circuit flow is indicated, is depicted. So let's bring in, and this is all drag and drop, let's bring in a battery. We can rotate it by just clicking on the endpoints, rotating it. Let's bring in a light bulb, because this is we want to build a simple light bulb circuit. I'm going to connect up the battery to the light bulb. Now, why isn't the light bulb lighting? Because in a circuit, you have to have a complete closed path. There must be a way for the current, the electric current, to return back to the battery. Once we've done that, here we see the light is lighting up. Now, if I click on the battery right here, I can use this slider to adjust its voltage. And you see that when voltage or power, and we see that when I increase the voltage, I increase the brightness of the light. When I decrease it, I decrease the light intensity. When I click on an element in the circuit, I can delete it by clicking on the trash barrel symbol. And I want to do that because I want to introduce a switch. And the switch works by clicking this joint right here, that little circle. When I click it, the switch closes, opens, closes, opens. Now let me restore the wire that we trashed before. And when I close the circuit, close the switch, the light bulb goes on. Now, let's do this. Let's add another light bulb into the situation. I'm adding, it's an unnecessary wire just to make things a little clearer. And I'll do this. And this is what's called a parallel configuration. And when I click the switch, they both go on. Now, let's remove this wire because I want to bring in another thing, another component called a fuse. And the way the fuse works is it's a protective device. If there's too much current going through the fuse will break. It's like a switch in that case, but you don't turn it on and off and on and off. Once it breaks, it breaks. You'd have to replace it. And the reason for that is you want to protect your house and the circuit when there's too much electricity flowing through it. And I can measure the amount of electricity going through it by putting in this current meter. It's called an ammeter. Current is measured in amperes. It's a measure of the rate of flow of the electrons with the current. I'll connect this up the wire, and fuses are rated, and we're going to select the rating at, let's say, 10 amps, which means if the current exceeds 10 amps, that fuse will break. So let's see what we've got here. We've got a rating of 23 volts. Let's turn the switch on. No problem. And we've got 4 amps going through the circuit. Let's increase the battery power. We're up to 33 volts. We're at 6.59 amps. 8.19 amps, no problem. Okay, oops, we got above 53 volts, that was too high. That got above the 10 amps, and the fuse broke. So anyway, that's a basic, simple simulation. You can try this out. You're not going to break anything. You may break a fuse, but that's the fun of a simulation. You can quickly reestablish your circuit. You can click down here, and that will erase everything, and you can start all over again. You can explore the use of a voltmeter. Here we have the ammeter, which measures current. The voltmeter will measure voltage. We just put this in the circuit, and we attach it to different points and see what the voltage is between those 2 points. So that's it. That's our little electrical simulator, and I hope that you'll try it out. Again, just go to the website, follow the instructions I gave you before, and have fun. And good luck.